Hi students, welcome to today's video. Today we are going to study about equations of motion for vertical movement of a body. You have studied about equations of motion. Yes or no? 8th lesson we have studied equations of motion. Are you remembering that? Yes. There are 3 equations of motion which are that V is equal to u plus at, s is equal to ut plus half at square. Then third equation, v square is equal to u squared plus 2as. Now we are considering a body which is dropping. We are dropping a body. When we are, there are 2 cases. One is a body is thrown vertically downwards. When a body is thrown vertically downwards, it is having initial velocity, final velocity, but the difference is its acceleration is acceleration due to gravity. And here, instead of distance travel, we will consider this distance is which thing? It will become height. So we are going to make slight changes and then to rewrite equations of motion, that is equations of motion for vertical motion. So here, see here, a body is here, then the body is thrown vertically downwards. So u, initial velocity, direction is changing, downward direction. So u becomes minus u, v becomes minus v, acceleration will be minus g and height will be minus h, because you know that when we studied y-axis, up thing is taken as positive, down y-axis is taken as negative. So when the body is falling vertically downwards, everything comes in negative y-axis. As a result, u, v and a is becoming minus g, s is becoming minus h. We are going to make these substitutions for our equations of motion. First one is v is equal to u plus at. So v will become minus v, u becomes minus u, then a becomes minus g and t. So minus and minus cancels from both sides. As a result, we are getting v is equal to u plus gt. Similarly, second equation, s is equal to ut plus half at squared. Instead of s, we are taking minus h, u minus u, then g is equal to, a is equal to minus g. So our second equation becomes h is equal to ut plus half gt squared. Here also minus sign cut from both the sides. Now coming to the third equation, v squared is equal to u squared plus 2as. v minus v the whole squared is v square, u minus u, and here g and h both are negative, therefore everything becomes positive. So v squared is equal to u squared plus 2gh. So these are the 3 equations when a body is thrown vertically downward. Now we are coming to the next case when the body is dropped freely. Dropped freely, the meaning is, it is, I am not going to apply any force on it. It is dropped like this, it falls down. See here, like this it falls down. So initial velocity u is equal to 0. Is it clear? It is not vertically thrown downwards, but it's kept and it is fallen. As a result, dropped it is. So u is equal to 0, v is equal to minus v, a will be minus g and s will be minus h. So apply that thing, substitute that in our basic equation, v is equal to u plus at, s is equal to ut plus half at squared, v squared is equal to u squared plus 2as. In that, when we are substituting these values, first equation becomes v is equal to gt. Second equation becomes h is equal to half gt squared, and third equation becomes v squared is equal to 2gh. So, downward motion we have two cases. One I am dropping, but it is we are throwing it downwards. That time initial velocity u is not equal to 0. But when it is dropped like this, somewhere you kept, automatically it is fallen down due to the gravitational force itself. That time its initial velocity of the body is equal to 0. Then we are applying it. Now we come to the third case, thrown vertically upwards, that is the upward motion. When it is upward motion, there is an initial velocity. I am throwing it upwards. So, initial velocity is there. Then acceleration a is equal to initial velocity u is equal to plus, then v, and acceleration will be equal to acceleration due to gravity, but it is against. Then h is equal to acceleration due to gravity, though it is this, but the direction is against gravity. So, g is taken as minus g, and h height is measured from the ground level to upward. So, s will become plus h. Therefore, the first equation is v is equal to u minus gt. Second equation is h is equal to ut minus half gt squared. Third equation is v squared is equal to u squared minus 2gh. So, this is equations of motion for a body in vertical motion, that is downward motion, dropped, and when it is thrown vertically upwards. Now, next we are coming to the next topic, mass and weight. You might have heard about mass and weight. Is there any difference between mass and weight? See here, when I say that the mass of this ball is 25 grams, the mass of this ball is 25 grams, you understood it. But the weight of this ball is, do you think the weight of this ball is 25 gram itself or something different? How do you know it? What is the meaning of mass? Mass means the quantity of matter contained in this body. That is, how much is the matter contained in this ball, which is called its mass. While weight means when I am freely falling it, what is the gravitational force acting on this body, that is when it is freely suspended, a gravitational force is acting on this body, that is known as weight of the body. So, how this is how we are measuring the mass of a body? You know, it's a common balance or a beam balance. So, an object is kept here in one pan and the units like 10 gram, 50 gram, 100 grams, that is kept in the next pan. As a result, when it balances, we say the mass of this body is equal to now 50 plus 10, 60 gram. Now, when we come to the mass, let us see what are the differences between mass and weight. When we come to mass, I said that mass is the matter contained in the body. So, mass of a body is the quantity of matter contained in it. Now, mass of a body is measured in terms of kilogram. How many kilograms? And it is due to, that is the measure of the inertia of the body. Earlier you have studied that more the inertia, more the mass for the body, then more inertia is there. Therefore, this mass is also called inertial mass. Now, mass is a scalar quantity. It is not having any direction. Mass, when I say that it is 50 gram, 10 gram, 50 kilogram, then it is not having any direction. Therefore, it is a scalar quantity. The unit, SI unit is kilogram, CGS unit is gram. Now, Mass of can the mass of this ball change when I take it from here to another place? If it is taken to US and I find the mass there, whether its mass will change? No. If we are not taking away anything from it or we are not adding any matter to it, its mass remains constant. Now, mass of the body is measured by beam balance or common balance that we had seen. Next, mass of a body cannot be zero. Even if you have a chalk piece, that chalk piece you are able to cut it and make it into chalk dust. If chalk dust is existing, that means it is having mass. So, mass of a body cannot become zero. Next, we are coming to the point weight. How? What is the difference of weight and mass? I said it is the gravitational force acting on it freely suspended. So, how can we do it? What can we do for that? We can suspend it freely suspended by a string. And then by using a spring balance, see the same object we had measured its mass. Now it is tied with the help of a thread and it's attached to the spring balance. What is its weight? Weight is equal to 60 gram multiplied by 980, that is the CGS, acceleration due to gravity. So, how much is the weight now? 0.588 Newton. What is weight? Weight means gravitational force acting on it. Now, weight of a body, it is the gravitational force acting on it. Mass is the quantity of matter contained in it. Weight is a force, the force acting on it. As a result, its unit is in terms of Newton. Now, if we are representing weight by W, W is equal to mass into acceleration due to gravity. So, W is equal to mg, then it is unit is Newton and we have to multiply mass by 9.8. Again weight, it is a force, it is a vector quantity and the weight of a body changes from place to place. Previous video you had seen that the acceleration due to gravity at a place depends upon the radius of the earth. Therefore, at equator and poles the acceleration due to gravity varies. At the same way, the weight of the body also varies from place to place. If the acceleration due to gravity at a place equal to 0 at the center, then it comes, the weight is changing. So, weight is measured by which thing? Spring balance. Then, weight of a body can be 0. Now, on moon, the acceleration due to gravity is 1/6 times that of the earth. Therefore, the weight of the body also is 1/6. For example, suppose the mass of a body is 6 kg. Its weight will be 6 into 9.8. So, I am taking 10. So, 6 into 10, 60 kg, 60 newtons. But the 60 Newton force, that is when it is taken to moon, what will be its weight? 1/6 times, that is 60 divided by 6, that will be 10 Newton. Is it clear? So, weight of a body on earth divided by 6, you will get weight of a body on moon. So, mass and weight, what are its differences? It is important. So, for today's video, we have seen that is the equations of motion for vertical motion and the difference between mass and weight. The remaining part we will see in next video. Thank you.